Welcome to lesson 1.3, which is the infinite limits. Now, in infinite limits, we have four theorems to discuss. But before that, let's know first what is an infinite limits. To make it short, let's have here the shortest definition of our infinite limits for you to really understand what is an infinite limits. Now, when we say infinite limits, the result is either a positive infinity or a negative infinity. Again, the result is either positive infinity or negative infinity. The result of the limit is either positive infinity or negative infinity. Now let's proceed to the different theorems. Let's start with the first theorem, which is this one. Okay, as you can notice, we have here two possible answers, which is a positive infinity and then negative infinity. Now for letter A, we have here a limit. The first theorem, okay, limit of the function 1 over x raised to r as x approaches to 0 plus or to the right, the result is positive infinity. It's just a hint actually. If the given is to the right or the approach, yung approach natin is to the right, then the result of our limit is positive infinity. Again, if the approach of your limit, okay, if the approach of your limit is to the right and then the function is um what do you call this, a function is 1 over a variable raised to an exponent, then the result is equal to positive infinity. Okay, now if your limit of a function 1 over x raised to r as x approaches to 0 minus or to the left, then the answer of your limit will be vary according to the exponent of your variable. So we have here the odd and even. These words are actually I do not know if you're familiar with this, but let's recall what are these numbers. So when we say odd numbers, it means that these are whole numbers that cannot be divided exactly into pairs. Odd numbers, when divided by 2, leave a remainder of 1, such as 3, 5, 7, and so on. What are even numbers naman? Even numbers are those numbers that can be divided into two equal groups or pairs and are exactly divisible by 2. For example, 2, 4, 6, 8, 10, and so on. Okay? So don't be confused with these numbers. Okay, now let's go back to the theorems. Now we can only say that the given is a negative infinity if the approach of your limit is odd number. Now if your approach is an even, I mean if your exponent is an even number, an exponent ha, yung exponent is an even number, then the result is positive infinity. Again, it can only be vary with an odd or even exponent if your approach is 0 minus. Pero pag 0 plus yung approach niya, or to the right yung approach niya, automatically the result is positive infinity. But if your approach is 0 minus or to the left, then the result may vary according to the value of your exponent. Like here in x raised to r, if your r is an odd number but your approach is 0 minus or to the left, then the result is 0, negative infinity. But if your exponent of your function here is an even number, then the result is a positive infinity. Now let's have an example for this. First example, we have here limit of 1 over x 12 as x raised to 12 as x approaches to 0 positive or to the right. Now as you can see, the result here is a positive infinity. Yeah, the answer is automatically is here. Okay, so don't be confused. Huh? Okay, the answer here is positive infinity because the exponent of our limit is, the approach of your limit is 0 plus or to the right. Now, when we say 0 plus, pag 0 plus na siya dyan, automatically the result is positive infinity. Okay, so don't be confused. Let's have another example for this. Now, if your limit, we have here limit of a function 1 over x raised to 5 as x approaches to 0 minus. The result is 0 ay negative infinity. Bakit negative infinity? Because, okay, the approach here is 0 minus, meaning to the left. Now, when we say if the approach is 0 minus or to the left, the answer will be vary. It's probably be an odd, I mean a positive infinity or a negative infinity. If the r or the exponent, again, the exponent of your variable here in the denominator will be an odd or even. Now, let's see the exponent of our variable here. That is 5, right? And 5 is what? It is an, okay, it is an odd number. Okay, it is an odd numbers. Okay, I don't know if you can clearly see this one, but it's an odd number. Okay, so since it is an odd number, then the result is negative infinity. Okay, okay, now let's have another example for this. For number 3, we have here limit of a function 1 over x raised to 2 as x approaches to 0 plus or to the right. Now, the answer here is positive infinity because the approach of your limit is 0 plus or to the right. So, automatically, pag 0 plus or to the right, yung limit, the result will automatically be equal to positive infinity. Again ha, do not be confused. Regardless if the given is an odd or an even number, pag yung approach niya is 0 plus or 0 to the, I mean to the right, automatically the result of your limit is a positive infinity. That's for theorem 1. Okay? Now let's have the next example. So we have here limit of a function 1 over x raised to 31 as x approaches to 0 minus. Now, as you can see, the approach here is 0 minus, meaning to the left. Okay, if the approach is to the left, then the answer of our limit may vary according to the value of the exponent of the variable in the denominator. Now, since 31 is an odd number again, so odd number, therefore the result, okay, the result is a negative infinity. This one, okay, negative infinity because your exponent here is an odd number. So let's have another example. What if the given is limit of 1 over x raised to 10, for example, as x approaches to 0 minus. Okay. If that's the case, look at again the approach. If the approach is 0 minus, okay, that is 0 minus, and then the exponent that we have here, for example, we have here the approach is positive 10 or an odd number, I mean an even number, sorry, then the result is, what do you think? Okay, that is an even number, so therefore the given limit is equal to positive infinity. Okay, sige. Naintindihan. Okay, so that is for theorem 1.